Hello, welcome to this video. Here we learn about data structure. Data structure can be defined as a particular way of organizing data in computer memory so that it can be used efficiently. That means data is stored randomly in the memory. So we have to organize in such a way that it can storage and retrieval can become fast. So basic idea is to reduce space and time complexity of different tasks or program that we execute on computer. Next is the concept of abstract data type. While organizing or storing data in the memory, we need to decide particular mathematical model. So abstract data type is defined as a mathematical model with collection of operations that are to be performed. The definition of ADT only mention what operations are to be performed, but how these operations to be performed that is are to be depends on the programmer. Programmer decide what kind of implementations or what should be performed in that operations. So it does not specify how data will be organized in the memory and what algorithm will be used for implementing the operations. It is it only tells about the operations. So it is called abstract because it provides implementation independent view. Next is the operations on data structure. So when we are using data structure, certain operations need to be performed. So here we consider commonly used operations or basic operations. First is insertion, deletion, searching, and traversing. Then sorting and merging. These six are common operations are performed on data structure. Apart from these six, there could be more operations depends on the application could be operation could be performed. So in these six operations, top four are called major operations and sorting and merging are called minor operations. So we'll see one by one operation. Insertion is nothing but when you add new element to the data structure, that operation is called insertion operation. Deletion, when we remove any existing element from the data structure, it is deletion. Searching means searching a specified data element in the data structure. And traversal is important. It is traversal is visiting or processing each element in the data structure at least once. Next is sorting. Sorting that means arranging data elements in the specified order, that is alphabetical order or ascending or descending order. Merging, when we need to combine two or more similar type of data structure elements or data structure together, that time we have to merge them, that is called merging. Next is types of data structure. Data structure broadly classified in two categories: linear and non-linear data structures. First, we'll see linear data structure. A data structure said to be linear if the elements form a sequence, or in other words, we can say that data elements stored in a data structure in a particular sequence or in a linear fashion. For example, array, linked list, stack, queue, and stack are linear data structures. In nonlinear, data elements are stored in a nonlinear form, that is either arranged in either hierarchical manner or connected in graphs. So that do not form a sequence. Data structure element do not form sequence. For example, tree where data elements are stored in a hierarchical fashion, graphs where elements are stored connected each other by arrows. Apart from linear and non-linear data structure categories, data structure can be static data structure and dynamic data structure. Static data structure where size of data structure is fixed and memory locations associated with it or size of memory required to store that data structure is also fixed at the time of compilation. For example, array where array size is always fixed. Dynamic data structure where certain data structure may shrink or expand or grow depending upon the need of the program and its execution. Hence, their associated memory locations are also changes. Such data structures are called dynamic data structure. For example, linked list. Linked list is a dynamic data structure. We see one by one data structure array. Array is a data structure used to store homogeneous elements, that is of same data type element in contiguous memory location or sequential memory location, where size of array must be provided at the start of the program, that is at the beginning, because it is static data structure where size is fixed. Most of the data structure make use of array to implement their algorithm. That means all other data structure, stack, queue, tree, and graph can be implemented or designed using array data structure. Apart from this, some of the terms need to understand with related to array, that is element. Each item stored in an array is known as element, and index is another important term related to array, where index represent location of each element in the array, that is numerical index or numerical order. In case depends on the programming language. In case of C, C++, and Java, index is always from 0 to size -1. For example, let's say we want to store marks of all students in a class, so we can use array to store these marks. Next data structure is linked list. Linked list is similar to array. It is a linear data structure where each element is a separate object or entity, where that each element is known as node, consists of two parts, data and the reference. That reference is nothing but the pointer that points to the next node. So therefore, we can say that linked list is a collection of nodes which are connected to one another through pointers. Stack is another linear data structure that operates on last in first out, that is LIFO principle. It is also an abstract data type which is collection of elements. Basically, it operates on two principles, that is push and pop. Push is nothing but when you want to insert any new element to the data structure, that time push operation takes place. And pop operation, that actually removes last inserted data from the stack. So this push and pop, both the operation takes place at only one end of the stack, that is known as stack top. Stack can be implemented or designed by using either array or linked list. Next is queue data structure. It is also linear data structure that operates on first in, first out principle, that is known as FIFO. It is also abstract data type which is collection of elements, and basically there are two principal operations performed on queue, that is NQ and DQ. NQ is nothing but process of inserting or adding new element to the queue. Now in case of queue, insertion operation takes place at one end or one side of the queue, that is called rear end. DQ is opposite to that of the NQ. DQ is the process of removing or deleting element from the queue. So DQ operation performed on other side of the other side or the other end of the queue, that is called front end. So queue has two ends, that is front and rear end. Similar to stack, queue can be implemented or designed by using array or linked list. Now tree, which is non-linear data structure opposite to that of the stack, queue, linked list. Now, in a tree, data structure elements, which are known as nodes, are organized or connected in a hierarchical manner. That means one is connected to multiple nodes, so that nodes are connected by edges, and this tree can be designed by using linked list or array. So here it is, tree can be shown like this: node A connected to multiple nodes B, C, D, so forth, so on. Graph. It is another nonlinear data structure. Graph is pictorial representation of set of objects or nodes where some pair of objects are connected to each other by link. Similar to other data structure, graph also can be implemented or designed by using either array or linked list. In a graph, interconnected objects or nodes are known as vertices, and the links which connected to these vertices are called edges. So therefore, mathematically it can be represented as a graph is a pair of set, where set of v comma e, where v is set of or group of vertices and e is a set of edges connecting the pair of vertices. So in a graphical way, it can be shown like this, where A, B, C, D are vertices, and these are the edges connecting to each uh, vertices. So in this graph, V is a set where set consists of A, B, C, D, E, and E is a set of edges where A, B, A, C, uh, B, D, D, E are the edges.